Electrocardiograph. It is a device used to obtain and display the conventional 12-lead ECG. The signal processing block diagram of electrocardiograph would be used for our reference. The components of electrocardiograph. Skin electrodes. Silver and silver chloride electrode covered in a chloride iron-rich gel attached to the adhesive mount. So the small changes in potential difference at the skin surface cause polarization of silver and silver chloride electrode to produce an ECG signal. Then amplifiers. ECG signal is very small, about 1 to 2 millivolt in the magnitude. They need to be amplified by an amplifier which provides voltage gain, which is output voltage divided by input voltage. The simplest type of amplifier is single-ended amplifier. There is one input terminal and one output terminal. The problem with the single-ended amplifier is the mains voltage from the lights, which is much larger than the ECG voltage. It appears at the input via a small natural capacitance. The amplifier amplifies both the signals, and ECG signal would be submerged and could not be detected. Also, the patient is earthed in this situation and it is an electric hazard. The second type of amplifier is the patient isolated differential amplifier. It detects the potential difference between the two electrodes applied to the patient whilst ignoring the induced electrical interference signals that appear equally at both the electrodes. So, 3 electrodes are connected to the patient, 2 inputs and 1 common point. For best results, common electrode is placed at a neutral point on the body, commonly right leg. The facility to ignore signals that are common to both input terminals is defined as common mode rejection ratio. It is differential signal gain divided by common mode signal gain. The common electrode could be earth and more preferentially floating. The third component of the electrocardiograph is modulator. The signal fluctuations are impressed on the light beam by using light emitting diode. Then fiber optic cable. It passes the beam of light. Photodiode. At the end of cable, the light is converted back to electrical signal by a photodiode. Demodulator. The electrical signal is converted back to its original form. Next comes amplifier. The ECG signal is further amplified. Then there are filters. There are 3 types of filters. Simple band pass filters, simple low pass filters, and simple high pass filters. Let's talk about simple band pass filters. So the resistor, inductor, and the capacitor are joined such that the resistive action of inductor and the capacitor oppose each other, and at certain resonant frequency, total AC resistance, that is impedance, will be at the minimum. Therefore, this filter passes a certain band of resonant frequency. The frequencies higher or lower will be attenuated. Then simple low-pass filters. It is the resistor-capacitor network which allows low frequencies to pass through it and removes the high frequency. It is used in EEG where High frequency muscle signals are prevented from passing through. It is also used in analog computation, control systems, feedback, analog digital conversion, and waveform generation. Simple high pass filters. The resistor capacitor network is arranged in a way that it blocks a DC input and passes high frequencies. Its application is in left ventricular pressure waveforms used as means of estimating the myocardial contractility. Then occurs digital processing. The analog signal is converted to a digital value by analog digital converter. The advantage of this is that after conversion, these values cannot change, drift, and become noisy. At the end, ECG signal is displayed on the computer.